everybody, I'm Nick Williams and this is Nik Clark. We are making this video to present our Ferris wheel prototype.
We wanted to design a Ferris wheel that simulates all the motions and movements of an actual Ferris wheel. We used a motor to drive it in both clockwise and counterclockwise directions at 2 different speeds. And we also implemented some loading and unloading features that show all the timing and allow you to select different cars to unload. We also added a user interface to make it easy to operate and a speaker system to play music while the Ferris wheel is in motion.
Alright, so we wanted to zoom in a little bit and show you some of the features and different components that we used for our Ferris wheel. First off, we'll start off by talking about the Ferris wheel. It's made out of K'NEX, and the reason why we chose K'NEX is because they're light, they're easy to build, and we already had this kit that was a Ferris wheel that we bought straight from K'NEX. We are running this Ferris wheel off of our STM32L476 microcontroller. The reason why we chose this microcontroller is because it has exposed GPIO pins that we can access, it has an onboard DAC, and it has timers that we can use as interrupts. We also have the most experience with this, and we already had it. We are then running our motor off of the microcontroller. It is a 5-volt DC stepper motor. The motor is also connected to a driver that allows us to put 5 volts through the stepper motor without having to run 5 volts through our discovery board. The motor is connected to our Ferris wheel by simply putting the axle of the stepper motor into a notch that we cut out of a K'NEX piece, and then putting heat tape over the top of that. As you can see, the Ferris wheel itself is very light, and so this stepper motor was able to produce enough power to drive the Ferris wheel, and also it was a cheap motor, and we already had it.
For our sound system, we considered utilizing a speaker and interfacing with it directly, but we found it was easier just to use this sound system here and interface with the auxiliary port. So this is just a 3.5 millimeter auxiliary cable, which we then modified to expose the signal and ground lines. We soldered these wires together and connected them directly to our discovery board. This discovery board has exposed GPIO pins that are connected to the DAC. The discovery board also has an audio jack available, but we found that for our use, it was simpler just to simply send the raw DAC output directly through the cable to power our speaker. For a keypad, we selected this 16-key keypad, which has all the functionality we need to control our Ferris wheel. The letters control the motion. These numbers allow for finer movements for loading and unloading, and the star stops all motion. So, for example, if I press the A key, we should see this Ferris wheel move in a clockwise direction at a slow speed, and music will play. If I press the B key, we should see the motion move a little bit faster. Pressing it now. There we go. If I press the stop key, everything should stop. If I press the C key, the music will start over, but we should move in the opposite direction at a slow speed. And if I press the D key, it'll move slightly faster. Alright, for finer movements, we have these other keys. So for example, we have a car ready to be unloaded, but if we wanted to unload the next car, I would simply hit 7, star. And it will move the precise distance it needs to. There we go. For finer movements, you can use smaller numbers. So if for some reason the Ferris wheel gets off, you can simply hit a 1 and move it just a small distance.
Alright everybody, thank you for watching this video of us demonstrating our Ferris wheel prototype, and have a great day.